We are given an array of positive integers. Evaluate the bitwise AND of every combination of number of candidates. Every combination of numbers of candidates. So we have some candidates and we have to evaluate the bitwise AND of every combination, every possible combination. Each number in candidates may only be used once in each combination. Okay. So there may be some combination of these candidates, uh, and we need to evaluate and of each of that combination. Return the size of largest combination of candidates with a bitwise and greater than 0. Bitwise and greater than 0. We so the combination should have bitwise and greater than 0, and we have to return the size of the largest combination of such kind. What kind? That the bitwise and should be greater than 0. All right. So what is the fundamental condition of bitwise and being greater than 0? So let's say these are few numbers. If we'll take and of all of these numbers, it will be greater than 1 only in the case where all of them will have at least one bit set and one same bit set. For example, this is 0010, this is 1111, this is 0011, this is 0110. So bitwise and of all of these will be greater than 0. Why? See, the second bit is 1 for each of these numbers. So after taking the and of all of these numbers, this will still be 1, and hence the number will be greater than 0. This is the minimum condition. What is the condition? At least one common set bit. Take a set bit. Okay. So now what can we do to evaluate the largest such combination? Uh, we can check for every bit what all elements are having that bit set. So we'll finally get a list which will tell us, okay, the first bit is set for 5 numbers, second bit is set for 7 numbers, third bit is set for 9 numbers, and so on. So now we'll be able to see, okay, the third bit is set for 9 numbers, which means that 9 is the largest combination that we can have, uh, which will have the and greater than 1. So we can create a boolean function to check set bit, which will take two numbers, int a and int n and int b, and this will check whether the bth bit of n is set or not, right? Yeah. And the first we are considering the first bit as 0. For example, this is, if let's say this is, these are the bits 1 1 0 1 1, then this is the 0th bit, this is the first bit, this is the second, and so on. Makes sense. So if the last bit is 1, yeah, this is the right shift operator, and yeah, in this case we'll return true, else we'll return false. Okay, now we will make a vector of how many bits. I think we can take 25, 26 bits, bit count. uh let's keep 26. Now for int I equals to 0 and I is less than 26, and we can iterate over all of them, all of candidates, and if candidate I check set bit for candidate I, what bit? Uh, okay, let's keep this I. Let's make this B, B. The bth bit. Check for the bth bit. If this is true, then make bit count plus bit count of B plus plus, right? And let's say our answer is initially 0. We'll make answer equals to maximum of bit count B comma answer, and we can now return the answer. Bit count, let's see if it is working. Okay, yep,